All right, I'm back. I'm on page 273. It turns out there's actually nothing for me to do on page 273 because 273 is an assignment for you to do. So what you're going to do is you're going to do each of these difference quotients. So difference quotients are essentially slopes. And well, these specific difference quotients are slopes. A difference quotient literally is a quotient, right? So division with a difference in it somewhere, right? Subtraction. So that's a difference quotient. These are the difference quotients. And there's two of them. So you got f of x minus f of a over x minus a. When you have that, it's going to be the limit as x approaches a. Then you have f of a plus h minus f of a over h. That's going to be the limit as h approaches 0. So there are two different things. The one with h is a little more common. The one with x approaching a is actually usually a little faster. But you'll see for various reasons we use the other definition. Difference quotient 2 is like 95% of difference quotients. But what you're going to do is for each of these types of functions, you're going to choose a value for a. You're going to choose a value for b. It doesn't need to be the same value in problem number 1 and problem number 2. You don't need to have the same a value, the same b value. Then you're going to choose a point in the domain of the function, and you're going to do both difference quotients for that problem. So in the end, you're going to do 12 difference quotients. Difference quotient 1 and difference quotient 2 always give the same answer. So when you do it, you kind of have a self-check. Make sure you're writing limits everywhere there should be limits. Make sure it's really clear what's in a numerator, what's in a denominator. Just do amazing, great work. Scan it, upload it. I don't know when this assignment's going to go out, but do that. So once we've done that, let's move on to page 274. All right, 274. Limits and infinity. All right, so there's two different things that can happen. One of them is x itself can go to infinity or negative infinity. That's option number 1. Option number 2 is as x approaches a specific number, the function will go to infinity. So these are two different scenarios. One, x is getting infinitely large, and then the second option is where the y value, the function value, is getting infinitely large. So two different infinite scenarios. It's also possible that as x gets infinitely large, so does y. But let's see what we're talking about. Lucky for us, this is kind of review from when we did rational functions because we talked a little bit about limits back then. There are three things you want to keep in mind, and we're going to force those to happen over and over and over again. The first thing, the limit as x approaches infinity or negative infinity of k, a constant. I went back to the thicker marker or whiteboard or whatever, like the thicker line, I guess. I liked it better when I zoomed out and could see that. So we're going to go with the thicker one. Who knows? All right, there's no x involved here, right? It's just k. It's just horizontal line. So since there's no x involved, it doesn't matter what x is doing. X could go to 5. It could go to negative a trillion. It could go to whatever. It can definitely go to infinity or negative infinity. K is just going to stay k. So nothing will happen there. The second thing is if you have k divided by x to the n, where n is greater than 0, if n is negative, then it moves up to the numerator, and it's actually a different form. But if you have k divided by x to the n, and x goes to infinity or negative infinity, you're going to get 0. So the way that I usually explain this is, let's see, let's use a color, let's say. All right, I'm going to do it up here. If you have k cupcakes, that's how I always explain it. If you have k cupcakes and you share them with infinity people, you get no cupcake. That's how I remember that. You have a finite resource, you're going to share it with an infinite number of people. Suddenly you intuitively know you're not going to get anything because if you share with 2 people, right? So if 2 people share it, let's say, you each get half. If you share it with 10 people, you each get 1/10. 1,000,000 people, you each get 1/1,000,000th. An infinite number of people, you each get 1 divided by infinity, which is 0. You get nothing. So if you have a finite number divided by x to the n as n goes to, as x goes to infinity, n is constant. As x goes to infinity, you're going to get 0. And then the third thing, bizarrely, people mess up. If x is going to positive infinity, then the limit as x approaches positive infinity of x must be infinity because x is x. I don't know a better way to explain that than like x is x. So if x goes to infinity, then x goes to infinity. So that's the third thing. All right, let's do some problems, and you'll see all of this in action. So here, this like straight up is thing number 2. So this, I like to highlight things with that color, but I don't like to just generally work in that color. So this will be 0 because of thing 2. You don't really have to like say why, but it's thing number 2. Here, this is also 0. So 10 to the 10th is big, but it pales in comparison to the square root of infinity. So this is also 0, also by thing 2. All right, now here's one where we want to do a little bit of work. So you probably don't want to do the work, but you're going to do the work because you're going to do outstanding work on everything that you do. We're going to break this up to the limit as x approaches infinity of 3 over x cubed plus the limit as x approaches infinity of 2 over x to the 4th. Then we look at those, and both of those are thing 2. And so we're going to get 0 plus 0 equals 0, again by thing 2, which you don't really need to keep pointing out, but I keep pointing out. All right, so how about this one? All right, so what I'm going to do is divide through by the highest power of x in the denominator. That's what I'm always going to do, highest power of x in the denominator, and that's what you're always going to do, especially with rational function. So I will get, all right, so I'm dividing everything I see by x cubed. So I get 1 over x minus 4 over x squared plus 7 over x cubed over 1 plus 5 over x squared. All right. Now, do you see thing number 2 4 times? I do. So when we look at these, if x goes to infinity, this goes to 0, this goes to 0, this goes to 0, and that goes to 0. So in fact, we get 0 over 1, which is 0. We use thing 2 like a million times. It's by far the most common thing that you use in these cases, especially rational functions, which like you're asked about a lot. So remember rational function, polynomial divided by a polynomial. I'm just going to keep on going. I seem to have changed color. All right, we're going to negative infinity, but if you notice up top, it doesn't matter if you're going to positive or negative infinity. Those things still apply. So I'm going to divide by the highest power of x that I see in the denominator. People don't like doing this step. You know, get over it. X 1 minus 3 over x. And then you can see it, right? It's going to be, if we wrote that, it'd be 0 over 1 minus 0, but that's just 0. And you knew that, and so you didn't have to write the 0 over 1 minus 0, but it's useful. So we get a limit of 0. All right, let's see. I'm going to do the same thing. Divide through by the highest power of x in the denominator. So this will give me the limit. Notice how I'm writing limit because there's still going to be an x in the problem. I get x squared. So this is interesting. That is not thing 2. I just got x squared by itself. Minus 3 plus 5 over x. Okay. Over 1 minus 8 over x. All right, now, what happens here? So I see a bunch of zeros, right? You're going to be 0. You're going to be 0. Negative 3 doesn't have an x in it. So if x goes to negative infinity, it just stays negative 3. Not a big deal. 1 does the same thing. 1 has no x's in it, so it just stays. X squared, however, x squared, as x goes to negative infinity, actually goes to infinity. So this goes to infinity as x goes to negative infinity. So we have basically infinity minus 3 is infinity divided by 1. So our final answer here is infinity. So the reason that happened was we didn't end up with thing 2. Thing 2 is like the greatest thing to end up with because it kind of like zeroes everything out. It just didn't happen there. And that's okay. How about this? All right, let's dive in. Limit as x approaches negative infinity of x squared minus 3 plus 5 over x over 8 over x minus 1. Okay, let's look at this, do the same kind of analysis. I see a 0 here, and this will be a 0. Negative 3 and negative 1 are going to stay what they are because there's no x's involved. This one, this will x squared goes to infinity, right? Because we're going to square negative infinity. You get negative infinity squared is infinity squared, which is also still just infinity. But look at what we have. We have our new color. We have infinity minus 3 is infinity divided by negative 1. So this answer is negative infinity. Turns out that that negative 1, that like positive 1, negative 1, the denominator, makes like all the difference in the world between getting positive infinity and negative infinity, which couldn't be more different. So big deal there. All right, let's see. Can we do this one quickly? It's not really about being quick, but also as you're taking notes, it probably feels like it's about being quick. Divide through by x squared. These are like not a big deal. Anytime we get a constant when we're doing this though, it's a horizontal asymptote, right? Definition of a horizontal asymptote, y equals k is a horizontal asymptote if the limit as x approaches infinity or negative infinity of f of x is equal to k. So when we're getting a constant, we're getting a horizontal asymptote, which is like a big reason that you do these, figure out asymptotes. I see 4 zeros and then 5 divided by 4. So let me say, therefore, y equals 5/4 is a horizontal asymptote of what function? Of y equals whatever, 5x squared plus 6x minus 4 over 4x squared minus 3x plus 8. Because we got a constant, where else did that happen? Okay, so for like A, B, C, D, and E, we also got horizontal asymptotes, but they were at 0. So anytime you get a finite number, it doesn't need to be positive, but a finite number, you got a horizontal asymptote. Let's see, divide through x squared minus 4, 3 over x cubed, 1 minus 6 over x squared, 1 over x cubed. I see a lot of zeros. I see x squared, which is going to go to infinity. And so I'm basically getting infinity minus 4, which is infinity, divided by 1. So this is infinity. All right, and then we have this one. This is a weird problem because this is not a rational function. But could the same thing work? I don't know. I'm going to divide through by 5 to the x, the highest powered thing in the denominator. So let's see. Divide by the highest powered thing in the denominator and hope that we can create a scenario where we guaranteed are looking at zeros, which I think is probably going to happen. So I'm going to have 5 divided by 5 to the x plus 3 to the x over 5 to the x, which is maybe the trickiest one. 4 divided by 5 to the x minus 1. All right, let's think about this. If 5 divided by x goes to 0 as x goes to infinity, then 5 divided by 5 to the x will go even faster to 0 because 5 to the x grows a lot faster than x. So this is definitely going to give us a 0. Similarly, 4 over 5 to the x, so that's going to give us a 0. 3 to the x over 5 to the x, we could think of as 3/5 to the x. So 3/5 to the x, just like do a couple of them, right? 3/5, and then to the second is 9/25, and then 27 1/25, 81 over 6/25. It's getting smaller. It's actually going to approach 0, or just think of what that graph looks like. that graph definitely goes to 0. Can I think of why that graph goes to 0? I mean, it's like the graph of, it looks sort of like, it looks like, what's it look like for negative x values? I don't even want to know. Let's say x is greater than or equal to 0. So if x is 0, I would get 3/5. No, I wouldn't. I would get 1. And then it just decreases. So it's going to decrease for sure to 0. Horizontal asymptote is 0. So this goes to 0. So overall, I'm getting 0. So the technique worked. So what are we going to do? To find these limits, we're going to divide through like everything by generally the highest power in the denominator. I'm going to say highest powered thing in denominator. And then we look for denominator. And then we look to use thing 1, 2, and 3. So let's say look for things 1, 2, and 3. So these are not, you don't lose sleep over these. They're not bad. But you got to know how to do them. And really it all comes down to divide through by the highest power of x in the denominator, or the highest powered thing, as we saw with 5 to the x, and then look for constants. Look for a constant divided by something that's growing, or look for just the variable, which will go to infinity or negative infinity depending on what you're doing. But that's it for this page. So I'm going to wrap this video here, come back, do more on another video. So I'll see you then.